Hi, my name is Riley McRae and I'm one of the tutors for this unit. So in this video we're going to be taking a look at mobility. In this situation, a 2D planar mechanism, although the concepts here equally apply to a 3D mechanism. So to start with, we'll take a look at the mobility equation for a 2D situation. So it's going to be n minus 1 multiplied by 3, where n is the number of links. So this will be our freedoms, and these will be our constraints. So this is going to be minus 2 times the number of single degree of freedom joints, minus 1 times the number of 2 degree of freedom joints. And this will give us the overall degrees of freedom of the mechanism. So this is essentially derived from our generalized coordinate work. So given a single link such as this, we can fully characterize it with 3 coordinates. In this case, an x, a y, and our theta. So each of these is going to be independent of one another and capable of fully explaining the system. So we can move in the x direction, we can move in the y direction, or we can rotate it. So when we start putting these links together to make a mechanism, considering them as just free-floating links for now, each of these is going to have 3 degrees of freedom, although we have to take one as our reference. So 3 degrees of freedom for each link, and all of the links minus the reference link. We get our n minus 1 multiplied by the 3 degrees of freedom. So that's where our freedoms comes from. So now when we start constraining these links to one another, say we use a pivot joint like this, it constrains the motion in the x direction and the y direction, and only allows 1 degree of freedom, that being rotation. So that's where we get the minus 2, because it's constrained 2 of its degrees of freedom. Similarly, for a 2 degree of freedom link, such as the one expressed here, it allows it to move in theta, allows it to move in what we could call x, and it constrains its y motion. So in this situation, it's a 2 degree of freedom joint, so we only minus 1 degree of freedom for it constraining only one direction of motion. Okay, so applying this to the mechanism here. So I'll draw it again so we can just go through it more in depth. Okay. So in this situation, we could have to first take a reference link, and in almost every situation, unless it's a free-floating mechanism, that reference link will be the ground. So this will be our link 1. So gone through now, call this one link 2, 3, 4, 5, 6, 7, 8, 9, and 10. And finally, any body that is allowed to move with respect to the reference state is essentially a link. So any rigid body. So this here, this sliding block, is also going to be a link. So the number of links is going to be 11. So now, moving on to joints, you might have noticed here, some of these situations are going to have, say these 4 here, are going to have situations where your number of links going in, well, you've got more than 2 links connected at one point. So what we do there is, again, similar to this, considering 1 as the reference, we define its relation to 1 as one joint, its relation to the other as the other joint. So if we call the number of joints here m, then m minus 1 will be the number of joints in this situation. So applying that to count our single degree of freedom joints, we'll have 1 here, 2, 3, 4, since this one counts as 2. This one will count as 3, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 as a joint between the sliding block and the ground state here, and this one will count as 2 as well. So that gives us a total of 13. So if we count this one as 2, this one here is 2, 3, and 2. So finally, we can count our 2 degree of freedom joints, which will be this one here. And again, this one is going to have overall 3 links gone into it, so it counts as 2 degree of freedom joints. So now we've done that count, it's just a matter of plugging it into the equation. So mobility is going to be 11 minus 1 times 3, take 2 times 13, take 2. Or 30, take 26, take 2, or 2. So our mobility in 2 dimensions is going to be 2 degrees of freedom. And you'll do a similar type of thing with 3D mechanisms, although in that case you're going to have 6 degrees of freedom for each individual link. And your constraints are going to apply, you're going to have a lot more different kinds of constraints you can apply if you have 3-dimensional motion. So that's mobility.